Hi, welcome to section 8.1, Review of Linear Inequalities in One Variable. Hopefully by the end of this, you all will be able to solve linear inequalities, and you'll be able to graph your solutions on a number line and write those solutions in interval notation. So, quick little review of inequalities. The less than sign means that you're going to go to the left on the number line. If it's greater than, you're going to be going to the right on the number line. If you have a less than or equal to or greater than or equal to, that means that you include that endpoint value in your solution. In general, when you're solving inequalities, it's a lot like solving equations, where you need to add to both sides. You can do that. You can subtract from both sides, or multiply both sides by the same thing, or divide both sides by the same thing. The only difference with inequalities is that you will switch the sign, which means going from less than to greater than, or greater than to less than, if you multiply or divide both sides of the inequality by a negative value. Alright, a little bit about interval notation. So, interval notation, what I would recommend is graphing your solution first, because interval notation is very visual. So graph your solution on a number line first, and then what you're thinking is, how far to the left does my graph go? Then how far to the right does my graph go? So you're going to do that left bound, comma, right bound. And then you'll use parentheses for excluded endpoints. So if you have a less than or a greater than, or if you have any kind of an infinity, because you can never quite include an infinity, there's always more in that direction. Those would use parentheses. Brackets are going to be used for included endpoints. So if you have a less than or equal to, or a greater than or equal to, you're probably using a bracket. Alright, so these ones are already solved for you. They're just an inequality. I want to make sure you guys are okay with the graphing and okay with the interval notation. Okay? So this is example 1. The first one I have is x is greater than 3. So if I were graphing this on the number line, I'm going to have 0, here's 1. 2, and 3. X is greater than 3 means we're going to start at 3 and we're going to be going to the right. In MyLab, in the program that you guys use for your homework, you guys may be used to open circles and closed circles. They use brackets and parentheses to try to get you guys better at interval notation. So what they're going to do is they're going to put a parenthesis at 3, since it's just greater than, it's not or equal to. And then we know that everything is going to the right because it's greater than. That's what the graph will look like for your homework. When you're doing the interval notation, you think, how far left does my graph start? Well, it starts at 3, comma, how far right does it go? It keeps going forever. We can see that arrow. It keeps going forever in the right direction. And in math, we're going to use an infinity for going forever in the right direction. Okay? Then, the 3 was not included since it's a greater than. We'll use a parenthesis. Infinity always uses a parenthesis because you can never include an infinity. So that's what the graph looks like. That's what the interval notation looks like. Okay? Next one I have in part B is x is less than or equal to 6. So on my number line, I'm going to go ahead and count up to 6. 1, 2, 3, 4, 5, 6 is right here. The less than or equal to means I'm going to include that 6. I'll use a bracket. And then the less than means I'll be going to the right, or to the left. So starting at 6, we're going to go to the left because it's less than. In the interval notation, how far left does it go? Well, it has an arrow. It keeps going to the left forever. So that's infinity, but it's infinity in the negative direction. So we call that negative infinity. Comma. How far right does our solution graph go? It goes right until it ends at 6, so it stops at 6. The infinity will definitely have a parenthesis because you can never include an infinity. The 6 will have a bracket because it is included because of that less than or equal to sign. So that's what the interval notation looks like for that one. Keep in mind, you do not have to match. Like, they don't both have to be parentheses or both have to be brackets. You can definitely have one of each. It's describing what's happening each direction. Alright, last one I have for you is in part C. 1 is less than x, which is less than or equal to 5. So on my number line, here's 0, here's 1, 2, 3, 4, and there's 5. So what's happening here is x is greater than 1, so that'll be a parenthesis at 1 going to the right. And x is less than or equal to 5, so we'll have a bracket at 5 going to the left. Since it's both of those things, we're looking at the overlap, it'll be between 1 and 5. We have the parenthesis at 1 because of the just less than sign. We have the bracket at 5 because of the or equal to part of that. For the interval notation, how far left does it go? Well, it starts at 1. Comma. How far right does it go? It stops at 5. Okay? So for 1, we're going to have a parenthesis. At 5, we're going to have a bracket because, again, the 1 had the greater than symbol. The 5 has the or equal to part of it. So that's why those look the way that they do. Alright, next up, let's go ahead and solve one. We're going to solve an inequality, and then once we solve it, we'll graph our solution and write that solution in interval notation. Okay? Alrighty. So for example 2, what we have here is 3 times 2x minus 4 minus 3x is less than 2x plus 3. If you imagine this to be an equal sign and imagine it to be an equation, what we would probably do first is distribute so that we can simplify each side. So if I distribute on this side, 3 times 2x is 6x, 3 times 4 is 12. We also have a minus 3x over here that we will deal with in just a minute. And then we can combine like terms on that side. 6x minus 3x is 3x. So we have 3x minus 12 is less than 2x plus 3. And just like in an equation, well, I like to get the x's together. So I'm going to subtract 2x from both sides. So now I'll have x minus 12 is less than 3. And then to get the x by itself, I'll add 12 to both sides. So now I have x is less than 15. Okay? So now that I have my solution, x is less than 15, I'll graph it and write my answer in interval notation. So my graph, here's 0, I'm just going to go by 5s. 5, 10, 15. X is less than 15, so I'm going to have a parenthesis at 15, and I'm going to go to the left. Okay? For the interval notation, you think, how far left did I go? Well, I kept going forever. There was an arrow, so that's negative infinity, comma. How far right did we go? We stopped at 15. The infinity always has a parenthesis, and then the 15 will also have a parenthesis because of it just being less than and not less than or equal to. So the graph and the interval notation are my answers for that example. All right, let's do another one. In example 3, we're going to solve our inequality. I've got a compound inequality for you. And then we'll graph our solution and write it in interval notation. So in example 3, what I have for you is 5 is less than 3x minus 4, which is less than or equal to 9. Okay? This one is a compound inequality. You'll notice that there's 2 symbols. And so that breaks it apart into a left side, a middle, and a right side. And so what ends up happening is instead of adding to both sides, you add to all 3 sides. Or instead of dividing both sides by the same thing, you divide all 3 sides. Okay? So you have to do the same thing to the left side, the middle, and the right side. We're still trying to get x by itself, which means I'm trying to get rid of the 4 and the 3. Those are the things in the middle with the x. So what I'll probably do first is add 4. To get rid of that minus 4, and whatever I do to that middle, I've got to do to all 3 sides. I have to do it to the left and to the right, so everywhere. And then what's going to happen on the left side, I've got 5 plus 4, which is 9. In the middle, the 4's are going to cancel out, that's 0, and that would just be 3x, which is less than or equal to, and then 9 plus 4 is 13. I still want to get x by itself, so to get rid of the 3, I'm going to divide by 3 since that's the opposite of multiplication. And whatever I do to the middle, I need to do on the left side and on the right side. So you'll notice there's all 3 sides instead of both sides. As hard as you guys want to get rid of a side, you can never get rid of a side. You might turn it into a 0, but 0 is still a number. So you cannot get rid of any of these sides. Okay, it's a 3-part for sure. So let's see, on the left side, 9 divided by 3 is 3. In the middle, 3 divided by 3 is 1, so we'll just have x there. And 13 divided by 3 is 13/3, which I'm about to graph it on a number line. I'm going to turn that into a mixed number just so I can see where it is a little more clearly. 3 goes into 13 4 times. 4 times 3 is 12, and the difference between 12 and 13 is 1. So that would be 4 1/3 as a mixed number. So when I'm graphing that on the number line, here's 0, 1, 2, 3, there's 4, and there's 5. So x is greater than 3, so I'm going to have a parenthesis at 3 going to the right. And it's less than or equal to 4 1/3, so 1/3 of the way between 4 and 5 is where that 4 1/3 is. We'll have a bracket because of the or equal to part, and it's going to the left. So that's what our graph looks like, is it's between 3 and 4. It includes the 4 1/3. It does not include the 3. Interval notation. How far left does it go? It starts at 3. How far right does it go? It ends at the 4 1/3, or if you want to put 13/3, that is fine as well. They're the same number, just written differently. The 3 will have a parenthesis because it's not included, and the 4 1/3 will have a bracket because it is included. All right? Oh, now it's your turn. You guys get to try one and show me how much you've learned.